All right. So what I want to do right now is I want to do a nice little overview of Chapter 8 and Chapter 9, going over the review. You have the review, you have all the answers to the review, you have the calculator steps, everything's in there. But what's nice about today is we can take a stop and go over what we learned. So in Chapter 8, right, in Chapter 8, we learned the first one, a one proportion z-test. Okay? A quick example of a one proportion z-test would be like HO, P equals 30% of people wear glasses. HA, we believe more than 30% of people wear glasses. So for a one proportion z, you have a fraction, we're dealing with a percent, and it's one group. Then we learned number 2, a two proportion z-test. An example of a two proportion z-test is the proportion of men who wear glasses is equal to the proportion of women who wear glasses. We believe that the proportion of men who wear glasses is not equal to the proportion of women who wear glasses. So in that case, we're dealing with two fractions, 2%. Okay? So basically, Chapter 8 is proportions, fractions, percents. Do you have one group or do you have another group? Okay? Chapter 9 is where we learn the other three cases. And in Chapter 9, we learn a t-test. So an example of a t-test is when you have a small sample, so let's say mu equals, you're supposed to get 8 hours of sleep at night. Well, we think college students with HO, we think HA is mu is less than 8 hours of sleep. Then we learned something called a t-test difference. Now, a t-test difference is exactly a t-test, but it's when we're comparing. The classic example, like a pre and a post test, and we're trying to see if there's a difference between the two. So for that one, you have to remember HO is always mu equals 0. 0 means no difference. No difference. And HA could be, yeah, we think there's a difference. Mu is not equal to 0. Then number 5, we have a two sample t-test. And basically, we have two groups. Like men hours of sleep equals women hours of sleep. And then maybe we believe men sleep more than women sleep. Okay? But those are the 5 scenarios from Chapter 8 and Chapter 9. Okay? My job today is I'm going to look at the review. And when I look at the review, I'm going to show you that they're so different. Because your concern is, how am I supposed to know which one's which? How am I supposed to know which one to do? My job today is to say they are so different. When you read it, you clearly know which one it is. Are we okay? That's my job today. Now, the other thing I want to focus on is when we talk about each one, I'm going to say which one is it? Number 1, number 2, number 3, number 4. So keep this list on the side. And some of you are still a little confused. When am I supposed to say negative means lower and positive means higher? Do I always put higher and lower? And the answer is no. We only put negative for lower and positive for higher when we're comparing. So which ones are we comparing? We're comparing when number 2 when we have two proportions. We're comparing in number 5 when we have a two sample t-test. And we're comparing for number 4. So when we do number 2, number 4, and number 5, that's when I have to say negative means lower, positive means higher. But for number 1 and number 3, I don't have to say higher or lower because we're just reporting the number. Are we okay? So these are little details that we're going to focus on. We good? So my job, again, I'm going to take out the review that all of you have, but I'm going to focus on the solution. I'm going to focus on the solution, and I'm not going to work it all out. I'm just going to point stuff out. I'm not going to work it out. I'm going to point stuff out. I'm going to show you the calculator, but the work is already done. You have to do the work on your own. Okay? So keep that list of 5 handy. Here's what I mean. It is reported that 27% of Americans with a smartphone have an iPhone. Stop there. 27%. If I'm dealing with a percent, 1, 2, 3, 4, 5, which ones deal with percent? 1 or 2. So it's either 1 or 2. I know that just from reading the first sentence. Now I got to find out, do I have one group or do I have two groups? So we keep reading. We did a random sample of 50 Americans with a smartphone and found that 20 out of the 50 have an iPhone.
Is there enough evidence at the 5% level that 27% or more of Americans with a smartphone have an iPhone? So, do I have one group or do I have two groups? One group. I asked 50 Americans, 20 out of 50. There's your one fraction. So it has to be a what? One proportion z-test. That's how obvious I want it to be to you. Does that make sense? And I know we've been learning a lot and it's all kind of get confusing. Today we're clearing everything up. We good? So again, I'm not going to work it out for you, but P, we use P, not mu, because we're doing proportions. P is 0.27. P hat is 20 over 50, which is 0.40. Remember, you need the fraction if you want to use the calculator. N is 50. Alpha is 0.05. And is this less than, more than, or not equal to? More than. Are we okay? So everything's in there that we need. Are we okay? Now, I'm just going to fly through it. HO is P equals 0.27. We read that it's going to be greater than 0.27. Be careful of the words you use. Am I going to say the average or am I going to say the proportion? The proportion. The proportion, the who and the what, of Americans with a smartphone who have an iPhone is 27% or is equal to 27%. And then HA, the portion of Americans with a smartphone who have an iPhone, is greater than 27%. Are we okay? Then every test has conditions, but the conditions are different. So for a one proportion Z, what are the conditions? Number one, it has to be random, stated. Number two, the population has to be greater than 10 times the sample size. All Americans with a smartphone is greater than 10 times 50, which is 500. And N times P greater than or equal to 10, and N times 1 minus P has to be greater than or equal to 10. All three conditions check. But each test has its own conditions. You need to know what the conditions are for each test. Are we okay? Then we do the work. All right, so when we do the work, we need to know our formulas. So step one, find your SE. How do you find the SE? It's the square root of P times 1 minus P all over 50, where you get 0.063. Again, you got to know how to type it in. Then you find your Z. How do you find your Z? P hat minus P all over your SE. You get 2.07. Now, how do we do this normally? We draw the picture. 2.07 is down here. We're looking for more than. We go to the Z table. If you look up 2.07, you find your p-value. But again, the table gives you less than, so we have to what? Subtract from 100. So we know how to do it by hand. But that's how you get the answer. I'm going to remind you how to do the p-value in the calculator. Okay? So let's go to the calculator. When we go to the calculator, and again, you may want to write down everything, right? So when I go to the calculator, okay, what do I press on the calculator? What are the buttons? Stat, test, which number? Number 5, one proportion z-test. Now what does the calculator want? What's P? What's P? 0.27. Now, the percent is 40%. Does the calculator want the percent?
No, fraction.
No. What does the calculator want? The fraction. X is 20, N is 50. Are we doing not equal to, less than, or greater than? Greater than. Then you go to draw. You can do draw or calculate. But then you go to draw, and it gives you the nice picture. So again, you do it by hand, and it should match what's in the calculator. Are we good? So what's your p-value? 0.0192. Now be careful, little mistakes. What percent is that? 1.92%. Now, alpha is 0.05. P-value, 0.01. The question we've asked a million times, is your p-value smaller than alpha? Yes. So when your p-value is smaller than alpha, what do you write? We reject HO. There is statistically significant evidence to reject HO, our p-value. We conclude that portion of Americans with a smartphone or have an iPhone is greater than 27. See how everything clicks? You got to know. Got to know if the p-value is smaller, then you reject. If you reject, there is enough evidence to reject, and it is greater than 27. Okay? Then the confidence interval. How do you do the confidence interval? There's the formula. P hat plus or minus Z star times your SE. 1 minus, 1 plus. Now, you got to make sure when you get the numbers, great, check. But when I explain it, am I going to say 0.277 and 0.523? No, what am I going to change it to? Percent. So you got to know this is the one we change it. Now, do I say 27 to 52% more than? No, there's nothing to be more than. It's just reporting what it is. We are 95% confident the proportion of Americans with a smartphone who have an iPhone is between 27.7 and 52.3. Yep.
For some reason, when I type in the calculator,
Now, it's giving an error. Go to y equals, see if you have a plot on. If you have a plot on, it could be that. If not, I'll come over and check. Now, let's go to the calculator again. And remember the numbers. Stat, test, which one is for the 1 proportion z? 1 proportion z interval now. Which one's that? 1 proportion z interval is all the way down to A. So you got to know which one it is. Again, your calculator is pretty smart, so it knows your next step is to plug in. What does the calculator want? The fraction. So 20 over 50. How confident? 95. Go to calculate. Now, it may be a little off. It's like 1% off. But remember, because of the rounding, it's going to be a little bit off. So as long as it's close, that's a great way to check your work. We good? 1 down, 4 to go. And that's kind of the overview I'm going to give for each one. But my job is to say, how different are they? Now, in that document, you also have step-by-step how to do it in the calculator. In that document, you have step-by-step how to do it in the calculator. So all the calculator steps are there for you. You just got to look at it. You got to use all those resources. Okay? Example 2. The researchers from Valencia College interviewed 2 random samples. So stop there. How many groups do we have? 2. If they are 2 separate groups, it can either be a 2 proportion Z or a 2 sample T. So we've already narrowed it down. Now, if it's a 2 proportion Z, you should have 2 fractions. If it's a 2 sample T test, you should have 2 numbers. Let's see what we have. The first sample from Osceola included 75 randomly selected students, and 50 of them are going to UCF. The second sample is taken from Lake Nona and had 70 students, and 40 of them are going to UCF. So do I have 2 numbers or do I have 2 fractions? 2 fractions, 2 separate groups. So it has to be a what? 2 proportion Z. And it tells you that we're looking for not equal to, and it tells you that alpha is 10. So there's the first group, Osceola. There's the second group, Lake Nona. The ends don't have to be the same. Alpha is 10. When we write our HO and HA, we're going to write HO is always equal. The proportion of students at Osceola who will be attending UCF is equal to the proportion of students at Lake Nona who will be attending UCF. And then HA, the proportion of students at Osceola campus who will be attending UCF, is not equal to the proportion of students at Lake Nona who will be attending UCF. And then the conditions. Remember, the conditions are different for every test. Why are the conditions longer for this one? There's 2 groups, right? So the first group, N1, P1, has to be greater than 10, N1, 1 minus P2. And then the second group, N2 times P2 and N2, 1 minus P2. Everything has to pass to move on. They got to be random. They got to be independent within the samples. And we always assume the null hypothesis is true. Now, then we do the work. The work's kind of the same. We got to find SE. We got to find our Z. We got to find our answer. But we have a little problem. And the problem is, which p hat do I use? The first or the second? The combined. The combined. So we add the numerators, we add the denominators, even though we're different, and we get a combined p hat. That's what we use in the formula. Be careful typing it in. There's your SE. P hat 1 minus p hat 2. Technically minus 0, but it doesn't change anything. Divided by your SE. There's your 1.18. When you draw the picture, remember, not equal to checks both sides. So when you draw the picture, we have 1.18, negative 1.18, and we're trying to find the p-value, which is both of them. If you find them separately, remember you get 1 and you multiply by 2, but the calculator gives you both automatic. Okay? So if we go to the calculator to check, Now we're gonna know what we're gonna push. So stat, test, which test are we doing? Two proportion Z. Now again, what does the calculator want? Two fractions. What's the first fraction? 50 over 75. The other fraction, 40 over 70. Notice you gotta put it in correctly. You gotta know how to do it. We're doing not equal to this time. Then we go to draw. And that's going to automatically do both sides for us. That's going to automatically do both sides for us. And we get our p-value. Okay, so it's the same picture we draw by hand. You can look in the z table to find the one side, multiply by 2. But our p-value is 0.23. Alpha is 0.10. Our p-value is 0.23, but our alpha is 0.10. So is our p-value smaller than alpha? No. So we fail to reject, or do not reject. It means the same thing. We fail to reject, or do not reject. So we write our conclusion. The p-value is not smaller than alpha, so we do not, or fail to reject HO. There's not enough evidence to reject HO. We conclude that portion of students at Oslo campus who attend UCF is not different than. Remember we have that little conclusion chart in our notes? The opposite of not equal to is not different than the proportions of students at Lake Nona. Now, we have to understand this. What does it mean? If Osceola had more students go to UCF, more, you would expect two positives. If Osceola had less students, you'd expect two negatives. But if they're not different, you should expect a what? A negative and a positive, which means it could be lower and it could be higher. So the work is p hat 1 minus p hat 2 plus or minus your SC times your Z star you get from the table. You get a negative or positive. Now, do I have to explain what the negative and the positive mean? Yeah, negative means it could be lower. Positive means it could be higher. Now, why do I do that? Because I'm comparing Osceola to Lake Nona. And am I going to leave it at 0.03 or should I put 3%? 3%. But before we write the sentence, let's check it in the calculator. So when we check it in the calculator, remember we did a two proportion Z. Now we're looking for two proportion Z interval. Which one's that? All the way down to B. Two proportion Z interval. Fractions are in there for us. How confident this time? Alpha was 10. So how confident? 0.90. Again, be careful. Make sure you change that. And we get our negative and our positive. Okay? We have to explain it. So the sentence is going to read, we are 90% confident the proportion of students from Osceola who go to UCF is between, how do I interpret that? Lower. 3.7% lower to 27.75% higher than the proportion of students at Lake Nona who go to UCF. Are we okay? So again, you have to do the work, check in the calculator, and be able to explain it to really, really understand it. Are we okay?
Yes.
That's one proportion, that's two proportion. Check, check. Now, again, all the calculator steps are in that document, step by step with pictures. Okay? The next one, right off the bat, what do you notice that you have? You have data this time, right? So this time you have data, you take the numbers, you plug it in list 1. I'm not going to do it, but that's something you can do at home. But you take the numbers, put it in list 1, okay? Now this one says, it is reported that the average weight of all newborns is 7.5 pounds. Is that a fraction? No. So we're not doing proportions. We're doing numbers now. And do we have one group or two groups? One group, one set of data. Okay, so this is going to be a t-test. We're doing alpha at 1%, and we're trying to find out if the average rate is greater than 7.5. Now, before we move on, they didn't tell me the X bar. They also didn't tell me the S. S should be here, and N. So where do I get X bar and S from? They didn't give it to me. You put that in list 1, and then you do stat, calculate, one variable statistics. Remember doing that? That's where you're going to get the X bar, and I should have put the S up here, but it's on the next page. Okay? But let's talk about details. HO is going to be mu equals 0.75. We're not using P, we're using mu. And we're not saying the proportion, we're saying the average. So the average weight of newborns is equal to 7.5 pounds. We're trying to say in HA, the average weight for newborns is greater than 7.5 pounds. Now, the conditions for a t-test are a little different. Was it random? Yep, should have been stated. What's the magic number for a t-test? Magic number for a t-test? 25. Do I have 25? No. So if it's under 25, we're going to go ahead and what? Assume it's normal. But technically, you're supposed to make a histogram of the data. If it's about normal, you can move on. So that's about normal. And then your population, which is all newborns, has to be greater than 10 times the sample size. So you got to check your conditions. Now, just like before, you got to find your SE and you got to find your T. So here's the work. Formula is a little different, but to find your SC, remember we got the X bar and the S from the calculator. You do the standard deviation divided by square root of n, that's your SE. X bar minus mu divided by your SC, that's 5.75. Now, we don't have a table like a Z table, but we've been drawing pictures for that. First of all, is 5.75 pretty big? That's huge. That's off the charts for us. So 5.75 would be way down here, and anything greater than that would be like a little speck. So our p-value is really, really small. But remember, if we're doing this critical value, our t, we're going to compare it to t star. To do t star, what two things do you need? The percent, which if alpha is 1%, what's the percent confident? 99. And what's the other thing we need? Degrees of freedom. How do you do degrees of freedom? N minus 1. So 15 minus 1 is 14. So you go to the table, look up 99 and 14, and the table will give you 2.98. That's like my alpha. That's like my p-value. So my p-value is this. My alpha is this. Is my p-value small? Really, really, really small. Now, we're going to find the p-value in the calculator. Which test is it again? T-test. T-test. So we go to the calculator. Stat, test, t-test, number 2. Now, I don't have the data in my calculator, but you can put the data in list 1, and you would reference list 1. I don't have the data in my calculator, so I'm going to do it the other way. I'm going to do it with stats, but either way is fine. Mu is 7.5, X bar is 8.68, standard deviation is 0.795, N is 15, and we're doing greater than. Now, anytime it's off the charts, what is our p-value going to be? 0, right? So because our t is so large, checking our work, our p is essentially 0. It's okay to report 0 because it's really small, but if you want to know the exact, stat, test, t-test, if you want the exact, what should I choose? Calculate. So if you want the exact p-value, choose calculate. Be careful. What's the p-value? It's not 2.52.
0.
What's E negative 5 mean? How many zeros? 4 zeros. 0.00025. Bottom line, super small. Is our p-value smaller than our alpha? Yep. So what do? We reject. So we reject HO. There is statistically significant evidence to reject HO because our p-value is so small. We conclude that the average weight of newborns is greater than 7.5. Okay? So we're saying it's greater than 7.5. So when we do our formula for our confidence interval, it's X bar plus or minus T star, which we got earlier, times our SE. There's all the work for you. We are 99% confident the average weight of newborns is between, do I say 8 to 9 more pounds? No, that makes no sense. It's just 8 to 9 pounds. We're not comparing. So between 8 to 9.29 pounds. And we can check it in the calculator. So if we do a t-test, what goes with a t-test? T-test goes with t interval. Okay, so go to your calculator. Stat, test, t-test. That's that one. We're looking for t interval. T interval is number 8. How confident? 99. And again, it's going to be close, maybe a little off, but it's going to be close to what we get. So again, the sentence is, we are 99% confident the average rate of newborns is between 8.07 and 9.29. Now remember, we rejected. We rejected 7.5. Looking at the interval, why did we reject 7.5? It's not in the interval. Our interval is actually greater than 7.5. See how everything's connected? We said it's greater than 7.5. Our interval is greater than 7.5. 7.5 is not in the interval. It all makes sense. Question?
So we would be able to just like type it in and calculate?
You have to show your work. Calculate for checking. Are we okay? So we did 1 proportion, 2 proportion, Z. We did t-test. Now the one that kind of confuses people, again, all the calculator steps are there for you. Now we're going to do this one. Now again, you're going to use your calculator to do this at home. This is something you need to be doing at home. I'm just going over it. But for this one, we have a pre to post test. And the idea is if I go to a workshop, will it improve your scores? So I really don't want the pre-test, and I really don't want the post-test. What do I really want? The difference. So remember, the way to do it, and you've got to practice this at home, pre-test in list 1, post-test in list 2, but in list 3, you go to the top in list 3, and you want list 3 to be list 2 minus list 1, hit enter, and it will do all the subtraction for you. Okay, we can practice that later if you like. But I'm trying to see if there's a difference, So when I refer back to data, am I going to refer to list 1, list 2, or list 3? List 3, because we're trying to see if there's a difference. And with a t-test difference, mu is always what? 0. So the average difference post minus pre-test is 0. We think that the workshop works. So we think that the average difference in post minus pre-test is greater than 0. So the one thing you have to remember about a t-test difference is mu is always 0. 0 means no difference. We're trying to argue that there is a difference. Again, everything else is the regular t-test. So we check our conditions, random, yep, assumed to be normal, population greater than 10 times the sample size. And then all the work is the same as a t-test, right? The x bar and the s we get from the calculator. You find SE, standard deviation, divided by square root of 9 in this case. X bar minus 0 mu divided by your SE, you get 1.21. Then you compare it to your T star, which is 95%, and degrees of freedom is 8, and minus 1. You get 2.306. If you compare the two picture-wise, your test statistic is 1.21. This is your p-value right here. Your t-star is like your alpha. That's right here. So is your p-value, that area, smaller than your alpha? The answer is no. But we can find it in the calculator. So again, because I didn't put the data in, I'll do it the data way. So if we go to the calculator, stat, test, it's just a t-test again. If I had the data in the calculator, which is what you do at home, you would use data and refer to the difference list where mu is 0, like list 3. But I'm going to do it with the stats because I don't have the data in the calculator. So mu is 0, x bar is 1.22222, standard deviation is 3.0322, and it's 9. This one is greater than. So draw, and the calculator does it for you. You get the same t, and you get your p-value, 0.13. So alpha is 0.05, alpha is 0.05, is your p-value 0.13 smaller than 0.05? No. So what do? We fail to reject, or do not reject HO. There is not enough evidence to reject. We conclude that the average difference post minus pre is not greater than 0. Not greater than 0. Then confidence interval, same thing. X bar plus or minus SC times T star. There's your work. So we are 95% confident the average difference in post minus pre-test is between, again, explaining the negative, lower by 1.019 to higher by 3.55 points. So does the workshop work if it's lower and higher? Does the workshop work if your score could go down or go up? No. Would you go to the workshop? No. It's not working. Your score could actually go down. Okay? If you want to practice the T interval, just like we practiced the T, we did the T test again, we're going to do the T interval again. We go to our calculator, stat, test, we did a T test, we go to number 8, T interval, put all the numbers in. Remember, this one is 95% confident. So we are 95% confident the average difference in post minus pre is lower by 1.109 to higher than 3.55. So it's not worth going. Your score could go down. I'm not going to pay for something where my score could go down. I want to go with something where my score can go up. I want it to both be positive, I want it to both be high. I want it to be worth it. Are we okay? So again, just a little review. We've completed number 1, number 2, number 3, and number 4. So the only thing left is a 2-sample t-test. So you tell me, if it's a 2-sample t-test, what should I have? How many groups? 2 groups. And I'm going to have 2 fractions or 2 numbers? 2 numbers. Again, they are so different than each other. That's what I'm focusing on today. So, all the calculator stuff, yada yada. So here, we have 2 groups of students that were selected in the study to participate. One group is the control group. They both have 30 students. They don't have to be the same. One group is the control group. They didn't get any notes. That they got an 80 with study deviation of 1.5. The group that got to use study notes got an 87. Which group do you want to be in, the control or the study notes? You want to be in the study notes because it looks like your score will be higher. That's what we're comparing. So first group, second group. So the average test score for the control group without the notes is equal to the average test score for the group with the notes. And we're saying that if you don't have notes, it's lower. The average test score for the control group without the study notes is lower than the average with the study notes. The conditions are the same, got to be random. You should have 25, but under 25 will be normal. All students taking the exam, 10 plus the 2 groups together. There are more students each day taking the class. And then the formula is longer. Why is the formula longer? 2 groups. So it's the square root of the first standard deviation squared divided by 30, plus the second standard deviation squared divided by 30. Get your SE. Once you get your SE, x bar 1 minus x bar 2, you get your T. Now, what do we know about that T? Negative 7.34. Is that really big or really small or pretty normal? That's weird. Negative 7. That's way out there. Mm-hmm. That's going to give us a really small, really small p-value. Our T comes from 95% and n minus 1. Remember which n do we use? The smaller one. This is kind of like an estimate. If we compare these 2 numbers, this is way on the outside. So we're going to get a really small p-value. We're expecting a really small p-value. We'll do it in the calculator real quick. So stat, test. Which test are we going to do? Number. Which number? 4. 2-sample t-test. We put in the numbers. The first group is 80. Standard deviation of 1.5. 30. The other group is 87. 5. 30. Again, they don't have to have the same number, but in this case they do. We're saying that the first group is lower, less than. Pooled is always No. Go to calculate and draw. We know when we hit draw because our t is so large that we're going to get p is 0. We're going to get p is 0, which is really small. But if you want to find the exact, again, that should be similar to your work. Stat, test, go down to number 4, but choose calculate. Remember that E -9 means you move it over 9 spaces. So how many zeros? 8 zeros. That's what gives you a really small p-value. Our p-value is definitely smaller than our alpha, so we reject HO. There is enough evidence to reject HO. Our p-value is essentially 0. We conclude that the average test score for the control group is less than. Now let me focus on that a second. It's less than. If I don't have notes, my score will be what? Lower. So am I expecting, when I do the confidence interval, 2 negatives, 2 positives, or a negative and a positive? 2 negatives. And when you do the work, x bar 1 minus x bar 2 times your SE and your T star, you get 2 negatives. How do I interpret the 2 negatives? If I don't get notes, my score is going to be what? Lower by 5 to almost 9 points. So we are 95% confident that the average score for the control group will be, without the study notes, is between 5.06 to 8.94, lower than the group with the study notes. So the last thing I'll do, we'll check it in the calculator. Stat, test, 2 sample t-test goes with 2 sample t-interval, number 0. All the numbers are in there. Don't forget pool is no. We are doing 95% confident. That's where I get the 2 negatives. Okay? Stop it there. That again, just to remind you, my job was to go over all 5 and show you how really different they are, and hopefully that worked. Okay?